Okay, so good afternoon, everyone. I'm Sebastiano Toffaletti, Secretary General of the European Digital SME Alliance. I'm happy to welcome you here for this workshop on analytics and AI in advanced manufacturing. I'm going to be co-chairing this meeting together with my colleagues from the Joint Research, European Commission Joint Research Center, in particular Daniel Nepelski and Sarah Nigris. I don't know exactly who among them will be. Certainly Sarah is going to be, taking the floor early because she's on the agenda, but probably Daniel is going to pop up a little bit later. The workshop is part of the focus group on artificial intelligence, which belongs jointly to the European Digital SME Alliance and to the European Commission Joint Research Center. The topic we want to address today is the situation in advanced manufacturing. What is the uptake in SMEs? What are the technology trends that are happening? And of course, what is the role of artificial intelligence and data analytics and so on in terms of opportunities for that particular application? We have a good agenda that you have all seen. So first of all, we want to give the opportunity to the JRC to present a study they have been carrying on advanced manufacturing. So we have Sarah De Nigris presenting that. Then we have a presentation from one of the members of the focus group, Dirk de Nutte, who's here with us, who is gonna give his own views, his own experience on advanced manufacturing. And then we have a case study which comes from an R&D exercise, a funded project in research, which is gonna delve a little bit into a case study of the medical devices sector. Following that, we're going to have some discussion and then a part of the meeting reserved to the members. So, as you know, what we're trying to do here is quite important, in my opinion, because we want to put really SMEs at the center of the agenda, and the objective of our focus group on AI is really to provide, first of all, to provide SMEs with a view on what is happening in terms of trends, political and industrial trends, and also hear back from these companies on what their needs are. In a feedback, so to say, in order to try to develop together a vision for the future. Indeed, you've seen this slide, I think before, those of you who are part of the focus group. This event is open, of course, to the members of the focus group, but it's also open to, upon invitation, to other external guests. What we want to really try to do with this group is put together the providers of artificial intelligence and the leaders in the application in the different sectors, be this logistics, agriculture, etc., and assess the different levels of maturity of AI usage, and of course derive certain recommendations for what to do with these technologies and its implementation. We know that the regulatory environment is becoming is very much on the focus, especially of the European Commission. We have seen earlier a proposal which is to regulate artificial intelligence through a system which is, very similar to what we have seen, the CE marking with conformity assessment for products that has been applied quite successfully in Europe for a very large variety of products and sectors. And the Commission is proposing to regulate AI, especially in the areas of safety, security, and ethical principles, using the same approach. So a standard, I would say, based approach with the CE marking on AI solutions. The members of the group, you certainly know, we are talking about over 150 companies nowadays, which have been selected to be really the leaders in this, only SMEs to be the leaders in this sector in AI. They are visible on our website, and you have the link there with an Airtable which shows the logos and the profiles of the companies. So these are the main, I would say, files and initiatives that the focus group has undertaken until now. So we are in this, of course, close discussion with the Commission on their ideas in artificial intelligence. So we started with a white paper. Now we have a proposal for legislation. So there is the Data Governance Act, which is another important piece of legislation which came from the Commission. And we are obviously accompanying this with events and workshops that help us on one hand understand what is happening, and on the other hand to provide input. So I think with that, the meeting is going to be led mainly by my colleague Annika Link, who's been in charge from the beginning of the FGAI quite successfully, and by the colleagues from the JRC. I will have to leave sometimes in 15 minutes because I have to jump to another meeting, but I'll obviously bear with you for the discussion until then, and happy to stay in touch with all of you. So perhaps I'll give it to Sarah to introduce the study that the JRC is being carrying out.
Thank you, Stefano. So now you see my screen, I guess, and it's also going to...
You should probably try to enlarge it. Yes, that one.
Yeah. I am like trying to start the slideshow, but it's, yeah, it works now. You can see in slideshow mode, I guess.
Yes, all good. Go ahead.
Perfect. Thank you. Sorry for that. So thank you very much for the floor. So I'm Sara De Nigris, and what we are presenting here today is a joint work with Hirji Radek and Daniel Nepesky, in which we are really trying to following the trail and the breadcrumbs of AI uptake in manufacturing, really trying to make sense of the data and build a bigger picture. So before starting, just a few glimpses of who we are. So we work in the AI Watch, which is an observatory for artificial intelligence of the European Commission, and more specifically in a task that looks at AI uptake. So basically, we are interested in the adoption of AI in the different sectors, and also at aspects related to the geographies and applications, so the variety of those in the different sectors. And also, we also sometimes delve into the specificities of a sector, and so how AI is declined in that sector. So in the past, we have considered health and also mobility. And so now, indeed, what we are eager to present today are a preliminary result in manufacturing. So just to set the stage, what we try to do, as the title says, is shedding some light on AI uptake. And to do that, we have different strands of data. But this data, of course, can show us just different phases of this AI uptake. For instance, if we look at scientific publications, they symbolized here with the light. The problem here is that those three strands have different embodiments, like the different animals, but still we are far from having a coherent picture of the whole animal of AI uptake, which is symbolized here by the chimera. So indeed, to make sense of the complexity of this problem, then the other part of our research really is looking forward to discussion with stakeholders and experts on the domain, so to enrich and create this whole picture of this complex animal, which is AI uptake. So, and this will be indeed our aim today, to really delve into this complexity and have like the full picture of the animal. So very briefly, the step I'll follow. So a few images from the data. I decided not to go too much in numbers, but more into topics. So I'll try to guide you in our preliminary results for scientific publication, patents, and also venture capital data. And then I will have a couple of slides on what I call the broad brushstrokes. Really facts, more qualitative at more qualitative level that look at specificities of AI uptake manufacturing, but also in its barriers. And then we will close on conclusions that are like actually open-ended, because I hope there will be a jump start to then delve more into discussion with you. So actually not the end, but the beginning of the discussion. So starting from our first strand of data, to have a glimpse of this research and development, we look at scientific publications. We did a topic modeling to do that, and to see basically how AI was connecting with the other topics that were emerging in scientific publication on manufacturing. So of course, our first topic being AI, we found that there are strong connections of artificial intelligence related technologies with big data, IoT, 3D printing, and digital twin, which is of course pretty natural, but the fact that those were like coming together in the papers was also showing us that there was really there's a big entanglement between the software, the AI algorithms, and their embodiments, like for instance the embodiment of IoT. Then we continued our research like hierarchically, and we then can appreciate that automation stems naturally from IoT and big data, while 3D printing and digital twin, they kind of flow into concepts related to lean manufacturing. And if we then continue downstream, we then have topics like supply chain management, which is strongly connected with automation and sustainability. And then sustainability, which also relates and connects with the lean manufacturing. So at the end of this chain from AI towards more high-level issues in manufacturing, we have this cluster, this triad made by supply chain management, sustainability, and lean manufacturing that is emerging really, really strongly in the connections of the papers. But this is scientific publication, so to have a more on the ground feel of what is actually going on on the field of at the intersection between AI and manufacturing, we also looked, as I said, to the innovation brought by patenting activity. So in this case, what you're looking at is a breakdown of the technological domains that appear in the patents, as I said, at the intersection AI and manufacturing. So of course, you have a big chunk, which is the blue one on computer technology. But then other three strands are very important, basically on control, IT, methods for management, and measurements. So really, this seems like to be most of the landscape of patenting in this AI manufacturing intersection. However, then we went like at a finer scale, looking at codes, the CPC codes that accompany each patent. And here there are similarities because this fine-grained taxonomy of CPC codes shows, again, that all things related to data processing and computational models are the strongest one. So the blue part of the wheel with the arrows. But then there is also a mirroring with respect to the codes related to control and data processes for management. So the management of processes is also mirrored in this fine-grained classification. But an important and actually kind of surprising fact was that a code related to sustainability issues, so climate change mitigation technology, which is a very specific one for sustainability, appears to be shared by more of the 7% of the paper. So there is even a translation independence in activity of innovation that are geared towards sustainability and climate mitigation technology. So it was actually something that was coming from the scientific publication towards the more technical domain of patenting. Then, as a last strand, we looked at venture capital data. So who is investing and which are the companies that are receiving these investments? So again, another plot, but here what you're seeing are companies. So each dot is a company, and the colors, of course, relate to the cluster they belong to, their activity. So in the center, we have the clusters related to software and ICT, the green and the blue ones. And in particular, there's one that is specifically geared again towards sustainability development goals. While at the rim of the network, you have clusters that are more specific. So, for instance, the purple one is biotechnology, and then 3D printing and industrial technology, which is basically all things industry 4.0 are like clustered together, and they lay at the top of our network. So within those companies, which are the ones that are receiving VC fundings and they are in the startup phase, so every dot a company, a startup, we also trying to understand how and who is doing AI, so to understand where AI is at the strongest. So in the breakdown, what pops to the eye is that printing and industrial technology, so industry 4.0, are the ones with the largest share, and also automated technology. More than 50% of the companies delve into AI technologies. Then we have a cluster related to software, so IT, information technology, and software as a service, which not surprisingly is not completely AI because it relates to the larger world of software. And then last, biotechnology, somewhat surprisingly, doesn't show a high degree of penetration of AI, but also outside tech, which is technology related to all things constructions, which more naturally are not so picking up the wave of AI. So coming from like these three strands of data, as I tried to articulate at the beginning, the picture is actually very different. And all this data come from specific domains: science, innovation, venture capital. So it's not so easy to recompose the picture. So to go towards that, let's have a look at the broad brushstrokes. First, specificities. I organize that in three strands: green, human, and technological. Let's start with the first. So AI appears, so we have heard a lot of experts, and so also delved in many reports that point to AI as an enabler for sustainability. So overall, increasing the efficiency, reducing the waste, improving the energy efficiencies of the processes, all are within the scope of improving the sustainability of the manufacturing sector. And so this stands really as a major possibility. Then for the human, AI has also the chance to take away the burden of labor in the manufacturing sector, take away the physical burden, and therefore it could be also a means to increase inclusion, so that workforce, which was not before considered as integral part of the manufacturing workforce, could be enabled by AI to enter this workforce. So really being AI as a vehicle for inclusivity. And third, from the technological point of view, the technological brushstroke, the data is heading for being massively pooled in what they are called in the data spaces for manufacturing, and will be created in Europe. So there will be a massive possibility for having the data flow in and be pooled for really untapping its potential. On the other hand, every coin has the other side. So looking at the green, for instance, sustainability certainly can be enabled by AI, but still, in order to reap those effects, those systemic effects, this deployment should be holistical along the whole value chain. An example of this could be taken from the automotive sector, where there is a balance between improving the efficiency of roads, but then the risk is to have more vehicles on the road. So in order to really go toward a more sustainable future, there should be a balance. And the same is actually required for sustainability to be effective in manufacturing. For the human, there is also, of course, the downside of the coin, that a massive increase and refinement of human-machine interaction is needed in order to really have workers to be augmented by AI. And also those workers should improve their skills or learn new skills in order to be able to adapt to the new environment. And so therefore this necessity for upskilling stands as a hurdle to be overcome. Last, in the technological strand, so in the technological brushstrokes, certainly data can be pooled, it can be shared, and there is this enormous vault that can be created. But as some experts we have interviewed pointed out, if you have the effects, those effects are rare, and therefore it brings to very rare data sets to train on. And also another thing that was somewhat surprising for us, those data sets are sometimes machine specific. So there will be a massive need of, for instance, transfer learning in order to generalize those data and help this training to be translated to other settings and other machines. So this is also a technical hurdle that stands along the way of AI uptake. So resuming, the data showed us, as I said, different glimpses of different animals. We observed that AI in the manufacturing papers is very strongly entangled with other ICT-related technologies like IoT, big data, or 3D printing. And at the end of the chain, there is also a big emergence of the sustainability cluster of papers. So it's really a strong signal in the scientific publications. And in the patenting activity, there is a bit of a mirroring effect, because there is a lot of monitoring, control, management. So really patents that delve into taking care of the flow of processes. But also there was a significant chunk that was relating to climate mitigation technology, so really geared towards sustainability, very much like papers. And last, venture capital. So a lot of companies in the 3D printing and industry 4.0 and automation sports AI, so a really big percentage, while for instance biotech is surprisingly low in the penetration of AI. So and last, in our brushstrokes, we saw that indeed, so AI is of course paving the way for a greener and more human-centric manufacturing. However, of course, there are caveats that are of technical nature, but also of social nature, really. So the human and machine interaction will be, for instance, a crucial focus for its effective deployment. So my last point, that was actually my first, these data all give glimpses of AI uptake, but from very different point of view, from very different domains. So as I said at the very beginning, what really helps us to recreate and to recollect this image of the chimera is actually interacting and engaging with stakeholders and experts and professionals. So really, I look forward to the discussion with you on this respect, because it's really what helps us making sense of the whole animal of AI uptake. So with this, I would like to conclude, and looking forward to discussion with you. Thank you.
Thank you very much, Sarah. And I'm sure there will be many questions on that, and I'm also looking forward to the subsequent discussion. But I think we should move on to Dirk right now. So I'm just going to hand over the floor to Dirk, and then yeah, time for questions afterwards. Thank you.
Thank you.
Thank you very much. Do you see my screen?
Yes, we can see it. Perfect.
Okay, perfect. Well, thank you, and thank you, Sarah, as well, because you've explained quite some topics that I was going to touch myself, which saves some time because you've done an excellent job on touching on the various topics. So thank you for that. I'll just kick off briefly by hang on, see if this is working. Yeah, by just challenging a few dogmas around AI and a few thoughts that I would like to challenge, just to start off with. Very often AI is referred to as being de-innovation or innovative, which I tend to say it is not. It's just a tool, and as a matter of fact, I love to compare it to the monkey wrench we all know. And a very interesting thing to know is that the monkey wrench and the computer algorithm, the basis for AI many years ago, they were invented in the same year, 1840. So there's nothing really new about AI as such at the base. And another dogma that very often is referred to is, well, the past should be a continuous improvement process from the past. The future is not an improvement of the past. On the contrary, I believe it's very often about disruption and thinking and acting and organizing in a disruptive manner. At the end, the light bulb was not invented through continuous improvement on the candle. So another thought around that, just as an introduction, is I like to call it the Guggenheim effect. And this is, I'm a very positive-oriented person, and a lot of people tend to say, well, technology is changing the world, but humanity as such is never really improving. We're going this vicious circles and circles. I do believe it's true, we're going in circles, but we're excelling each time again, seeing things from other angles, from other perspective, and each time better and better. So I like to refer to that as the Guggenheim effect, creating a positive image. If we use technology well and right, we are improving, and also humanity will improve. And a lot has to do with the way we look at things, the way we think, and the way we organize our lives and our businesses. We used to work and think in a very centralized manner. Even look at our very centralized structures in the past. In the 80s, 90s, we started moving very decentralized structures. I like to refer to one of the godfathers of a decentralized structure was our CEO at the time at ABB, who really started thinking, creating profit centers. He said we have to have companies that have different micromanagers. Micromanagement is a wrong word here probably, but you understand what I mean. Whereas today, how things are evolving today, everything is being looked at, is being organized in a very distributed manner. And this for the human brain and humanity is very difficult to grasp. And it's exactly here that AI can assist us human beings in organizing our businesses and our lives. Is this distributed way of thinking and acting. And as a matter of fact, if you look at that, you talk about the future, it's maybe good to stand still at the crossroads, a visionary crossroads. What do you believe in? It's maybe a question we should ask ourselves each time again. You think nothing's really going to change? It's a bit, you know, the future is an extension of history, or should we just add lifelong learning? Or is it more than that? Is it more about the collaboration between humans and robots and artificial intelligence? Or do you believe in the doomsday thinking of singularity, where AI computers will take over our lives and rule on us? Personally, I believe in the third option. I think, and also Sarah clearly mentioned that the true story is in a combination of lifelong learning and collaboration with technology. When we talk about AI and where can we use and why AI in industry, there are just a few, not all of them, topics I would like to touch. And the first one is things, and Sarah, you referred to this as well, things have to be more agile, faster, greener, sustainable. We want things personalized, and we want it now. And that's what we see in our manufacturing environment, and especially in the SME environment, is we're moving from mass production to more mass customization. And it's exactly there that AI can support us in organizing our industry. So that's one trend that I think is important to understand where the value can lie. We all have heard about converging industries. We all understand and know the story about Kodak. How was Kodak taken away by the camera, the digital camera, by our digital phones, by our smartphones? How the mobility world is changing. Car manufacturing will change into offerings of mobility. Television will disappear. Netflix type of approaches will take over. The way we look at television, the way we capture news, the way we communicate news and deal with news. So this is also a phenomenon that's very important to understand the value of why AI. Of course, we all know, we've understood it's about exponential change. But again, like distributed thinking, it's very difficult for us human beings to grasp what is exponential change and speed. And I often make a simple comparison. If you do 30 linear steps, probably have a comfortable stroll to your mailbox. If you take those 30 steps in an exponential manner, you walk 26 times around the world. And that's the difference between that linear pattern and that exponential pattern. Very difficult for us to grasp. And that's where I like to refer to AI also has a role to play in the globalization. And I would like to say into the new globalization, because there is a paradox to the globalization. Today, it's very much a sub-optimized institutional harmonization and convergence we live at. Through AI, I strongly believe we can move towards a sort of new globalization where we get into an institutional diversity, a heterogeneity, which can only yield for the best for every human being, every nation, and every culture, I strongly believe. So as a matter of fact, it can be used to set new scene, to set new standards in a new competitive advantage for us as European entity. And it's for that specific reason, if you take that all together that I refer to, we're really living a new renaissance, because if you compare to the first renaissance, I mean, everything is changing politically, economically, socially, technology, science, and on a global scale, and at the same time, only at a much quicker and bigger speed than at the time. But as then, again, in this new renaissance, anthropocentrism, putting the human being in the center of our decision-making, what we do, how we apply AI in an ethical way, looking at sustainability, I strongly believe that this is a new way, and I like to call it a new renaissance. If we go back to Da Vinci, he invented the 2D perspective. Again, the human being in the center of everything, and I think that should be the core, always have that in the back of our heads. And indeed, today we move into the 3D era, where we have our Belgian company Materialize, who's very well known as a trendsetter, or more than that, a technology setter in that field. It's like getting back into a new time machine. I like to call it a time machine from Gutenberg to Zuckerberg. Well, exactly the same is happening again today, only at a much, much faster speed. It's not going to take that long. On the contrary, we're really moving into very interesting times, and this time machine is going to be at the speed of light, where the know-how will be for the machines, will be for the AI, will be for the technology to deliver us the answers. We as human beings, as entrepreneurs, as people who work in the industry, and especially focusing very creative SME environments, we will be there to define and deliver and understand to know why. So the AI and the technology can help us with the know-how. So if we look at a few quick but pragmatic applications where AI is in the manufacturing world applied today, there are a few fields I would like to touch, and taking the time into consideration. One of them is OE. We all understand what we mean with OE, the overall equipment effectiveness, but it's mainly looking and addressing the process optimization within our plants. A very important driver to maintain our efficiency and our competitive advantage. We in our company at Grain, we have a few examples that we have delivered for customers, playing into one of the parts of OE, because OE is about performance, it's about availability and quality. These are the three main components of OE, where we focused on solving at a larger steel plant quality and downtime issues with AI solutions. We have other examples in Solvay. I will refrain to give too much information now in view of the time, but it gives you a clear idea on what we can do with AI in the field of OE. Furthermore, predictive maintenance, equipment availability, looking at asset health, also a project we've done, asset health and performance optimization is a very important solution, or a very important value. It's more than a solution, value that we can bring into the industrial environment. So predictive maintenance has a lot of benefits to gain from new technologies and AI. Production, if we look at production, and not only the production where we talk about the OE, but also when we look at the organization around the production, we look at the planning and the scheduling. A lot is to be optimized there, and a lot is to be gained in efficiency for the final outcome of what we produce and how we produce. Also there we have developed some very nice products in our company around adaptive batch scheduling and so on and so further. Another field of applications to move on, and I'm just giving a few mindsets here, is MRO, so maintenance, repair and operations, is in the field of inventory optimizations and supply chain. And not only the inventory inside the plant, but also incoming streams of supply chain, outgoing streams of supply chain. These can be optimized in such an efficient manner and yielding so much value that it's incredible. It's really optimizing to the last percentage that you can gain. Important again for our competitive advantage and our agility in the market. Computer vision combined with AI, also thinking about augmented reality to support our people in their job, be it at maintenance or be it in any other field of expertise within our plants. So that's also a field we can optimize in. Robotics, I think, needs no explanation. We have all heard a lot about robotics. Goes for itself, speaks for itself. Digital twins, also touched by Sarah briefly. Very efficient when we talk about product development, design customization, but also for existing plants in shop floor improvement or improvement on our assets or on our planning. Agile analytics, taking sensor data, optimizing and analyzing and optimizing from sensor data. And last but not least, generative design, using machine learning to mimic the engineer's approach. You bring in the data, type of material, format, the goal of what you want to develop, you bring in all the necessary information, and through AI you can really have a generative design. Very interesting topic that I believe one of my colleagues will be touching later on this afternoon. So yeah, we all realize that there's a lot of AI benefits. Not going to link it too much, but it's about decision making, improving and accelerating out of decision making through real-time data and insights. It's about capacity increase. We talked about production planning. Well, clearly it's about increasing our capacity by optimizing our processes. Accelerated growth and expansion. As we improve our OE, we'll also improve the growth and the expansion of what we can produce through line and how we can bring it to market in a quicker and faster way. The improved supply chain has been mentioned already earlier. Also, through computer vision, we talked slightly, or I mentioned very quickly, the fact about computer vision and quality issues, but also safety issues can be detected and optimized in real time in plants. The hyper-customized manufacturing, personalized manufacturing, very important. We've got a few also examples here on shoes, but I'm also thinking in the medical world where mission will be treated in a personalized manner and will be manufactured for in a very personalized manner as well. So there's a scope of opportunities there that AI can have a crucial role to improve. When we go back a bit to the plant and to the maintenance level, we talk about RCA, root cause analysis, something that today is a methodology to define the root cause of a defect of an asset or trying to find the failure mode. Today, it's very much a manual methodology. Well, thanks to AI, we can improve, accelerate the root cause analysis process and embed that in our maintenance plans, improve what we call the fracas loop, the continuous loop of improvement of our maintenance planning. So it's a very valuable leverage as well that we can create through AI. I will not talk too much about this, but eliminating common and special cause effects in a nutshell means when we have defects or we have failure mode appearance in a asset environment, they're all caused by what we call technical matters or by organizational matters. Organizational meaning human matters, how the company is organized, how the company is planned, the more operational hassle we can have. Well, those two those two impacts on our assets, which is a very statistical approach, can be optimized through AI as well, and give us quicker, better insights in how much more we can yield from a specific production line under certain circumstances. So it's about reducing cost. Now, great benefits, but there are also some pitfalls when we talk about AI in manufacturing, and it's still very young. But one of the pitfalls, I believe, is we should not try to use AI to endeavor to outperform the experts, because we have plenty of experts in all disciplines, be it manufacturing, production, planning, maintenance, and so on. But it should rather enable us to test our hypotheses and support our way of thinking, so we reinforce our decision making. So don't try with your AI solution to outperform the expert, because that would be a wrong approach. AI does not determine, but helps us to articulate the right assumptions. So it's very important to make the right set of assumptions before starting a AI project. For instance, would another assumption lead to solving another problem? Or are you putting the right questions for the right outcome? So it's very important to have the end in mind. The outcome in mind is something that's very important when we start an AI project. Often we are used to get into a field of data and lose ourselves in doing smaller proof of concepts, and lose ourselves in those proof of concepts without really generating any value at the final outcome. Is a very specific pitfall that we have encountered a few times before with customers. We also tend to look at other weaknesses that we find amongst the data, where it's very important to address the existing weaknesses that are part of your primary assumption with the end in mind. Very important to take that specific approach before engaging. I like to refer to it as the POC trap, the proof of concept trap, and the fact that if we are not sure that we can industrialize and scale, then it's better not to get into the AI project as from day one. So it's very important. So yeah, we talk a lot about data and clean data. The thing I would just like to mention here is data, of course, is very important, but it's not really thinking in terms of clean data, because that would assume that we're talking about clean data. It's going to be accurate, it's going to be reusable. Clean does not mean it's valuable data, and accurate does not mean it's useful data. So that's also a pitfall when getting engaged in specific AI projects. That's why I believe we should really look into creating anti-fragile AI by focusing on what really improves and accelerates our decision making, and really supports the human being behind the project in what he or she should do and enable. So I've discussed briefly, I skipped a few slides here to accelerate, but the most important thing when engaging in such a project is indeed, as Stephen Covey once mentioned in one of his books, is start with the end in mind. Sounds simple, it is simple, but it's very often forgotten. And as a closing thought, and Sarah has referred to it a few times, sustainability and ethics is one of the most important and valuable drivers behind AI. And in 1962, John F. Kennedy already had, I think, a very visionary and smart quote when he said, "The earth, the sea, and the world, the globe, is a concern of every nation. And science, technology, and education can be and should be the ally of every nation." And I strongly believe if we apply AI in the right manner, with the right ethical values, with the right sustainability vision behind us, AI is there for the better of us all. And I think that was a very visionary quote all those years ago in '62. So thank you for your attention, and be following the rest of the conference. Thank you.
Thank you very much, Dirk, for this really inspiring words as well. And I hope that participants have also, taken some inspiration from that. I would like to hand over to Elias, please, and then afterwards we can enter into questions and discussion. Thank you.
second. I think you can hear me now, and probably now you can also see me.
We can see the screen, we can see you, and we can hear you. Yes, everything
That is fantastic. That is all you need. Okay, great. So let me start presentation in full screen. And actually move this. Okay. Oh no. Just give me 1 second because I'm having a little trouble to hide the. Okay, that should probably suffice. Okay, great. So, hello everyone. First of all, I would like to thank you for attending the workshop. I would like to thank Sarah and Dirk for the amazing presentations, and I would like also to thank my colleagues from Digital SME for organizing this and inviting me to speak about such interesting topics and advancements in the industry. So without further ado, welcome to my presentation on the Kyklos use case and specifically digital manufacturing and artificial intelligence inside the circular economy. So I will start with a little bit about who I am, and then I'll move on to the good stuff, let's say. So my name is Elias Ornadzis, and I'm a mechanical engineer by training. I graduated from the National Technical University of Athens, having studied design and robotics. So there I encountered for the first time the field of additive manufacturing, with which I totally fell in love with, and further pursuing, let's say, that profound love for the technology and its endless possibilities led me to TWI Hellas, where I work as a project leader in the Kyklos 4.0 project, where I am also coordinating the activities of Work Package 4, responsible for the Kyklos Product on Demand framework. So let's start a little bit with the basics. So what is Kyklos 4.0? So Kyklos 4.0 is a European-funded project that aims to show how cyber-physical systems, data-driven modules, lifecycle assessment, augmented reality, and artificial intelligence technologies and methods are able to transform circular manufacturing. So all this towards the ultimate objective of achieving increased energy efficiency, reduced material waste, customer centricity, and on-demand manufacturing. With the opportunity to actually bring this technology and knowledge to European SMEs through exploitation and 2 open call funding rounds. So the consortium brought together to achieve this is consisted of 29 partners from 14 countries working together for 48 months towards this. So now, as promised, let's move on with, let's say, the more spicy stuff and give you a little context about what I'll talk to you about today, which is nothing more than our activities towards achieving mass personalization inside the Kyklos project. So mass personalization production, to be exact, is a subset of the mass customization movement, and is defined as the ability of a company to custom tailor the products in accordance with its end users' tastes and preference. So therefore, involving the customer in the production process and shifting the focus towards customer demand. So to understand how mass personalization is fitting into the current status quo, let's very briefly at the history behind production paradigms. So as we can see to the left of the slide, during earlier years of the Industrial Revolution, craft production was the principal approach, providing handcrafted products tailored to the user's requirement in limited series and at high cost. Then in the early 20th century, as we all know, Henry Ford introduced the concept of mass production, where large amounts of standardized products could be produced through production, assembly lines, and human labor. And then mass production grew significantly until the late 20th century, where the introduction of flexible manufacturing systems such as numerically controlled machines, CNC machines, manufacturing management systems, and robotic systems were introduced in the industry, giving birth to mass customization. So going into the 21st century and the introduction of digital technologies and communication protocols, the possibilities at the moment seem infinite. So by leveraging web configuration technologies, data management systems, for example, manufacturing executive systems, as well as digital manufacturing systems such as additive manufacturing, companies are working towards covering high demand of highly personalized products at lower cost with more efficient supply chain mechanics, and thus paving the way towards true mass personalization production. So it is clear that mass personalization production workflows are able to provide highly variable products with high customer involvement, in theory accomplishing all this with increased productivity and an affordable unit cost. So having said all that, I will present to you, let's say, our take and how we bring enabling technologies together in one of the pilot use cases of the Kicklers project towards achieving product personalization. So we do this by bringing together 4 core technologies to be able to adapt to customer requirements, reconfigure our products, and provide them with custom personalized solution. So the 4 pillars, if I may call them, of this use case are, first of all, artificial intelligence, additive manufacturing, parametric design, and online 3D modeling. So we bring these technologies together to tackle the following problem. So as you all can see here, this is an atomic wheelchair. One of the pilot partners of the Kicklers project is designing and manufacturing these wheelchairs for the elderly and disabled patients, specializing in the fabrication of highly configurable, let's say, postural wheelchair cushions for the back and for the sitting. However, there is one part in the wheelchair assembly that has proven to pose a significant problem for child patients, and this is the design of the footrest component. So these components are manufactured in a standard way, letting the feet of the patient just rest on top of them. However, when talking about children, where feet size and leg weight are significantly smaller than those of adult patients, this component does not permit the feet to rest properly on the footrest. So this causes significant problems for both the patient and the manufacturer. Number one is, as you can see, patient discomfort, which leads to patients resulting in DIY solutions such as securing the feet with Velcro tape, zip ties, or even attaching bigger shoes on the footrest to actually fit the smaller child shoes. The whole situation is kind of a mess. So for the manufacturer, this is a standardized design that clearly doesn't serve their customer by simultaneously using a fixed amount of material which is clearly not needed. So having stated the problem, how do we plan to solve it? So what is our ultimate goal and the design considerations towards achieving it? So we answer this by providing a personalized footrest component tailored to each patient's anthropometry through the use of deep learning, parametric design, and on-demand additive manufacturing inside the production chain. So here I will present to you our high-level approach and then proceed on breaking down each individual stage. So we first start with the user providing, let's say, a picture of a drawn outline of their shoe. So then through the use of deep learning, we analyze the contour of the shoe and extract the appropriate dimensions from the digital image, as you can see, extracted from the piece of paper. So we do that to configure a parametric component of our redesigned footrest, which runs on the web via scripting modeling. And by exporting then the file in the appropriate format, we can use additive manufacturing technologies to provide the patient with a custom component tailored to their specific anthropometry. So let's now delve into the specifics of each stage. As mentioned, the user is able to provide a picture of their shoe contour by accessing a dedicated web platform and uploading their picture. So the tool is programmed so that it can cover the complete spectrum of classified, let's say, children's shoe sizes from a number EU 22 size to EU 37. So running on the back of this, we have trained a powerful deep neural network using our own pictures from people inside the consortium to receive a shoe contour as input, as you can see on the left, and provide the digital information as output. So by further analyzing the calculated contour, we are able to extract 3 principal dimensions. These are the shoe length and the top and bottom width of the shoe contour. So once we accurately estimate these 3 numbers through the use of deep learning, we then use them to update a 3D model of the footrest component, which uses as independent variables the 3 that you can see here on the screen: the radius of the heel R, the length L, and the angle phi, as you can see on the right. We have chosen these 3 variables through anthropometric analysis and expressed all other design parameters in terms of these 3 variables. So after calculating the independent variables vector, the personalized footrest is generated. And as you can see, it has been designed to use the exact amount of material needed to contain the patient's feet in just the right fitting, as well as to be fully realizable through additive manufacturing. So by using the proposed framework and testing it to different shoe types and sizes, we are able to generate a variety of personalized footrests using a robust framework that provides us with watertight geometries that are fully manufacturable through additive processes. So as you can see here in the next slide, we are not only able to realize a personalized component, we can do it on demand using less material while simultaneously achieving customer centricity. And we are also able to cut the production time to around 6 hours using FDM technology. So we do this all through a dedicated web platform accessible from any patient anywhere just by drawing their shoe outline in an A4 paper and uploading it to our tool. I try to keep this short and into the prescribed time, let's say. This brings me to the end of my presentation, and to conclude, by using artificial intelligence and additive manufacturing as enabling technologies, and consequently parametric design and web configuration as the means, as the tools to do it, we are able to use agile manufacturing ecosystems such as the Kiklos project to provide SMEs with true mass personalization capabilities. And I'll leave you all with one small Easter egg. You can access the technologies developed inside the Kiklos project and also test your solutions. We currently have a funding opportunity for SMEs, providing solutions to digitalize manufacturing processes. So the deadline for the application is by the 30th of June, and you can find more information on the Kiklos website. And you can always, of course, contact my colleagues from Digital SME if you have any questions. And so closing this presentation, I would like to thank you very much for your attention. You can always find me at the email address below, and you can also access the link presented for more information on the Kiklos Open Call. I will leave this here if you want to take a screenshot, and I will be more than happy to answer any of your questions. So thank you.
Thank you very much, Ilias. And with that, I think we can open the floor for questions. And I would also like to hand over the moderation to Daniel and Sarah, who are really interested in hearing your views on these topics, and to get additional feedback. I think there may be a number of questions that Sarah may have also to ask to the people who are present, to the community. So yes, a short opportunity. If you want to raise a question, you can just unmute yourselves and turn on your camera and ask it, because I don't think there's such a high demand. Or we can just do it with a chat, that you would just put your name in the chat and say, okay, I want to raise a question. Once you notice that it's getting really busy, you can do that. So I can see that Stelian is trying to, Stelian,
First of all, thank you very much for the opportunity. Yes. Can you hear me?
Yes, perfect.
Can you hear? Oh, great. First of all, thank you very much for the presentations. Really interesting, really hard work behind these presentations. Just starting with something comics, I would like to ask Sarah about what kind of mythical animal she can associate the AI based on the data analytics from different database sources.
Well,
because I can imagine I see a kind of with many heads, many interesting things. So
Actually, I wanted to go. You know, there's a Greek god Proteus. This, you know, the god that takes many forms, and proteiformic in means indeed like, you know, many forms, many shapes. So I would have gone with that, but actually in the iconography I couldn't find a nice picture of it. So this is why I went for the chimera, which was a little bit more, you know, flashy. This is so you actually got a weak spot there, because I would have made another choice of you know, mythical entity for AI, but.
And now more serious question. Yeah, that was a kind of introduction to break the ice. Yeah, we have seen that there are many researches and connections between AI and the other, let's say, advanced technologies used in manufacturing sector. Nevertheless, as you concluded, we still have a challenge in terms of identifying the proper ecosystem for companies to integrate AI with this technology in different kind of use cases. So in this respect, I'd like to ask you about what do you think which would be the major challenges for manufacturing companies in order to accelerate the adoption of AI?
I'm sorry, Stilani, is this a question for me? Because at some point my network flickered, and so I didn't hear the beginning.
Yes, you asking about the barriers you see in front of manufacturing companies that have to overpass in order to accelerate the adoption of AI, just because we imagine this, let's say, complex perspective of generic term AI, and yeah, how do you see the possibility to tackle this situation for an SME, for example?
So actually, you know, my understanding is the understanding of someone that looked into data. So I would rather pass the question to Dirk, perhaps, who is really on the ground and like facing the problem every day. Then, you know, I can like bring some like news from the science front, but I don't know, Dirk, perhaps this is actually something you're like facing every day. So perhaps your insights are like stronger than mine, I guess. You're muted, I think.
Yeah, Dirk, if you like to unmute your microphone, because we cannot hear you.
I think he's having some connection issues.
Yeah, exactly. I saw him present. So I will like just like give a few glimpses if you'd like of what we have understood so far. So for me, the biggest conundrum that actually I will be super happy to listen from, you know, SMEs that are on the ground and running, how is going down, is the following. So when so in the past I did some AI myself. So when I was developing a solution for some use case, Dirk, yes, we do.
Okay, I'm really having some issues here, but I'm happy. Sorry about that. I do apologize. I will try to answer the question, Sarah, if you could just rephrase it very quickly.
So what are the major, you know, challenges for, especially for SMEs to have this AI uptake, you know, going as, you know, fast and, you know, faster, stronger, better? And what's your experience in that?
Examples with SPG, which is a typical SME manufacturer of air-cooled condensers for
Yeah, Dirk, I think I'm not able to hear you. I don't know, Stellan, if you can, but
may I have a comment still? Dirk is coming back. So there is two phases. We have AI embedded in some technologies. That's fine. I mean, if you have an AI embedded in a robotic system, that's okay. You will integrate the robot, will program, that's okay. That is one issue. Or if you have a 3D printing which is smarter than the traditional one because of AI, that's fine. It's a matter of higher performance of that technology. But is the second layer where companies generate data and they have to use them in order to improve, to optimize their processes. So from my perspective, these are two layers, and I'm not concerned about having a technology which has already embedded an AI and make things faster, smarter, etc. But the other side, where the company should enhance their capability by using their basic resources, which are data coming up from their processes, and build up their own ecosystem led or driven by AI to make things being more agile, etc. So this is my focus for the second aspect of using AI in SMEs, for example. Thank you.
So you see as a problem, or go on, Dirk. It seems that we can hear you better now.
I don't know what's happening because I have plenty of those meetings, and today everything runs in the wrong manner. But no, I did hear what Brad was saying. I agree, and if I'm right in what I captured, it's not about creating more data. It's leaving or starting with what you have. There's so much data available, also in the manufacturing. When we first talked and said, let's put some sensors, let's try to gather information, where our experience is today. Many companies have information, maybe not structured, maybe not, but is it coming from your SAP system, from another CMMS system, from a MES system, from a PLC, but also from NLP, natural language processing. We use it, handwritten notes, voice recordings. We have so much data that we are unaware of. That's maybe a chaos, but you can really depart from that field, from that green field. So that's in. The other thing I was saying is working top down, having the buy-in of the management. That's what I thought was very important. Otherwise, you stay stuck at the technological level, where AI and the benefit and the value of AI goes much more beyond that. So probably it's much easier to start off with than you think if you do it the right way, with, as I said in one of in my presentations, with the end in mind. And I don't want to sound very theoretical, but we've done plenty for a young company, but we've done quite a lot of different projects today, and we have to learn ourselves because we made the mistake ourselves in the beginning. Let's get some data. Let's produce data. Let's try to smash the data into the system. No, you can do it much quicker and easier than that. But if you don't have a plan to scale, to hyperscale what you're doing with AI, my advice would be, and it's against my business now, is don't start. The of AI and our technology is really yields its value when you can scale. And I had the opportunity to listen to a presentation of the global digital AI manager of UCB, a large company, UCB, and he said exactly the same. And even financially, he said, if your ROI, that's very challenging for us, if your ROI is not 300% beyond your clock, don't do it. 300%. So that was quite an allegation that made me think before starting a project. Just to give, yeah.
Yeah, it's actually savage as an improvement. That it's really an ambitious goal. But what I was trying to say before, I mean, it started as a challenge for me when I was like on the other side, where I was like developing code. And so it's actually a question, you know, for the audience. When I was at that position, I had to make products that were really tailored for the company, really looking at their data, their problem, really the fine grain. And so there was really this, you know, this report with the entrepreneur, and the product was, it was very difficult then to take it and bring to another company. Really, it was looking at the finer scale of the data. So my question here, you know, for SMEs will be, if an SME doesn't have the capacity of having in-house that expertise, exactly as it happened in the past, it can prove challenging then for companies that are servicing AI to make products for them, because they are highly specialized, or is there still some translation that can be done of the same tool? And therefore, a lot of SMEs can be served by a same, you know, software as a service or AI on demand on demand company. Because I see for SMEs, it could be a problem to have that expertise in house, you see, and really have like this vision, as you're saying, Dirk. But you know, still, this is like something that definitely for me stands as a challenge, and I don't see a clear way forward.
If that's a question to me, I hear what you say, and I fully agree with you. But that's exactly, if you look at SMEs, because you refer to as SMEs, I think it's at the start you should really consider it not as a proof of concept, not as a project, because that's what they often do. You have to look at your company as being, this is going to be a digital transition that I want to engage in, because it's interlinked. It's just not, it's going to be my process, because you can, because they're to be linked and interconnected. You move out of your silos. It's cross-silo thinking and working. So the first step is really being convinced that this is the step you want to make, and then of course you have to be able to make that. But A, there are plenty of companies today that can assist, and B, the AI is becoming more and more playful in apping as well, for some applications that I see today that are becoming easier and easier to apply to start off with. So I think it's a strategic decision at first, a really strategic decision, not like what I've seen is, hey, this sounds interesting. Everybody's talking about Industry 4.0. We should engage in a project. Let's do proof. The 4 customers that said from top down, this is a new vision, this is a new strategy, we're getting into the full transition, and they're making that roadmap and they engage. That's where I feel the traction is taking up very quickly and very successfully. But it's
yeah. But so yeah, you know, my second question would
May I have a comment? May I have a comment?
I would also like to jump in if possible. Daniel Lepelski speaking.
Yeah,
so,
let Daniel.
Serian.
Yeah. Okay, very short something. I would say that I also believe that not all SMEs will be capable by themselves to tackle this problem of adoption of AI, but I really believe in the potential of innovating business models in order to enhance their partnership with specialized companies that can support them. So maybe it's a more matter of working more and more on the business model innovation in terms of open innovation and in terms of, let's say, more holonic structures for collaboration, such as to have this capacity brought in the SME for specific projects. And in my opinion, this is an opportunity for specialists in AI to set up, to establish new businesses on an emerging market. Thank you.
This is if I may, Sarah.
Sure, absolutely.
Yeah. I agree with that, Brad. And as a matter of fact, the example of this company, this manufacturer, which is SP tooling, This is how it happened because they didn't have the people to do it. So we helped as a request from the technical team who said, we want to do a proof of concept in predictive maintenance. Can you help us? We're going to install sensors, we're going to capture data, we're going to approve the installations we built at our customer site. We very quickly saw as a company that this was going to be like a POC trap that I talked about. And then we started talking to the owners of the company, the financial director, everybody was included. Within the first 2 months, we came to the conclusion that that was not the right model. They wanted to change their business model into a servitization model. And they said, we want no longer to sell our installations, but we want to sell energy to Luminous, to Engie, etc. So help us build a new model, a new way of thinking, and implement that in your AI tool. And that's what we've been doing. It's now 2 years ago for that specific customer. So it's indeed, as you say, Brad, is rethinking their business model and helping them through AI and technical AI implementation, help them build a new business model, which is from an engineer, a manufacturer of air-cooled condensers, into somebody selling servitization modeling to their final customers, selling energy and energy performance on the grid for the final customer. So this was a very interesting journey that we've done with this SME. So I very much agree.
Maybe a different perspective from my side. I think the exchange, I'm Yatandar from Lux on Lux. I think the exchange is really rich and we are all learning from the other's perspective. One aspect that we found it was difficult at having an exchange platform because different partners, they have different needs. And we found particularly promising the AI for Europe platform, where we find there is now building onglet on assets, another one on expertise, another one on marketplace. Maybe we could leverage more for SMEs on this platform. We particularly found it useful. It is still ongoing and is developing. We see a lot of developments coming from research and some industrial pilots where we can learn from each other's, let's say, each other experience in working with external partners. So we found it really valuable. It's still ongoing, it's still developing, but maybe now there is a potential for us as SME to engage more with the platform and have an important role there. It is a European platform.
Emilia, can I ask you a question about this? Is more
Sure.
about data or about code or about both? You know, the sharing of the, you know, value on the platform, just, you know, for me to picture.
Yes. So the platform is mainly seeing assets as being algorithms or modules, which are related more to the way computation is done. It is not related with the data being raw or being value added with expertise. So this platform is specifically meant for expertise, assets, and the marketplace. And the assets, they are not data. And I think it will need cooperation with other hubs where we have the data hubs, vertical based. It needs to collaborate with that. So if us as SME would like to use it without using our own data or the client's data, and we don't have any data, we'll need on top of the FOU also to collaborate with data innovation hubs or other partners which have valuable data. Did it answer your question?
Yeah, no, absolutely. That was exactly my point. It was related to what was my experience myself. I mean, the code sometimes you can translate a bit, even if it is difficult, but then you still, you know, have really the blend with the data, and then, you know, that's just an extra step. But you can create value out of, you know, sharing code. So I guess this is really in the same direction of like creating a critical mass out of it. Mm-hmm.
Yes, and I think on top of that, we realized that we could provide also expertise. So it's not only the coding, because we have code available on open source, then we don't know the reliability of it, because we have the robustness and the trustworthiness of those components that we're providing to our partners. So we take some risks. Being a European shared platform and being led by several players, we think that the power of the crowd could make it robust and stable, and thus long as we have several SMEs which engage, and that will grow organically to be trustworthy and stable. So from that perspective, we found the added value.
I see. So in some sense, you're. Oh, sure, Daniel. I'm sorry. Please go ahead.
I don't want to interrupt the discussion because I have another comment or another question. So if you want to finish that thought.
Oh no, it was just about this effect that Emilio was pointing to, the fact that the different shareholders could really contribute towards, trustworthiness out of these like distributed intelligence. And so I said there was a very powerful concept there. So just a comment on that. Please go ahead.
Thank you. Sorry, I hope you can hear me.
Perfectly.
Unfortunately, I cannot switch on the camera because I had to quickly install the app on my phone and I messed up the settings. So sorry, I would have to disconnect myself and connect again. Anyway, my question or my comment or observation is the following: that what I have seen so far, in the presentations that both Ilias and Dirk they were giving, was that mass customization or mass personalization can be seen as a kind of like a common denominator, or very strong common denominator across the projects that we are looking at. And my question is the following: taking the example of Ilias, I personally found it very interesting and actually quite fascinating, because we are speaking here about application that is extremely niche. So if this can be applied, if this can be done in the context, for example, of footrest for wheelchairs, this can be practically done anywhere. And then my question is the following: given that, Ilias, all the technologies that you were describing, AI, additive design, 3D design, or parametric, that was additive manufacturing, parametric design, we are not speaking here about, I would say, rocket science, So these are relatively technologies that are available more or less off the shelf. So my question is basically, what, in your opinion, can be seen? And I'm getting back to the question that Stelian was posing at the very beginning. What are the challenges to scale that? So that was also the point that Dirk made. That what can we do to really take it to the market? Or in other words, how personalized is this mass personalization model that you develop? So I don't know if you can elaborate on that, but I personally find it quite interesting. We have a technology that is more or less off the shelf. It can be applied nearly anywhere. So why it's not, or what prevents it from being deployed in other areas? Maybe also in the area that you studied.
Yes, thank you, Daniel. That's actually a very good question, and that it's something that we are also dealing inside, let's say, our consortium, because as you said, this is a niche market, and we want to see technologies that are be able to go out, let's say, of the niche market and into the actual market and be applied to different products, different SMEs. In my opinion, and as I have encountered it up to this point, there was a decision-making process involved in selecting the part. So as you said, there are some conditions that will be that will need to be achieved for us to be able to say that, okay, this can be actually put inside a production chain, and trust that an artificial intelligence algorithm will be able to update a model, a parametric model that will be robust, and it will not fail, and it will not have errors being generated again and again and again when a customer wants something, a product to be personalized. That is the one thing, in my opinion. So it's the decision making of how and where we actually apply this, because as you can see, the footrest component is something that is really simple. If we take this to other geometries, complicated assemblies with different parts, then the problem becomes a totally different thing, which is also the real challenge here. And in my opinion, from my side of things, that's the one. And then it's something that I'm not really the expert one of actually giving information on this, but how I've seen it is, okay, the question of, we did this, we generated the part, the customer, let's say, uploaded their picture, we have the parametric footrest, it is robust, it will not probably fail, and we can integrate it into, let's say, a commercial solution. How do we provide it? The supply mechanics, let's say, how do we move the parts, the raw materials, who's doing what? The whole procedure of the supply chain is a totally different thing, which is also really, really complicated when being done semi-automatically. That's my opinion on this.
So we are speaking again about redefining, really making a transition of the existing, in principle, about redefining, no, and recreating new business model, rethinking the way we are doing. That was also popping up in the discussion today, I think, no?
I agree with this, and I will go back to and give the floor also to Dirk, who wants to say something. It will go back to his presentation and go to the specific word which says disrupt, which is how we need to change the whole way of doing things.
I think that's Elias, thank you, because you just summarized it. This is, for me, it's not the technology which is impeding us, not at all. I remember I gave you an example about this personalized Nike in New York, where you step into the Nike shop, they measure your foot, you have a coffee, and later on after the afternoon you have a coffee, hamburger, you pick up your personalized shoes, because your right foot, everybody has two different feet, as a matter of fact, slightly different. It's made perfect to your feet. Incredible. It's exactly what you're talking about. No, it's too disruptive today. I think technology is ready, but it's how we organize. When I said about this new globalization paradox, everything is converged into something. Why we need to diversify again our business model, our thinking, and technology right now is looked at. Take another example, blockchain in the financial world. We can talk as much as we want about blockchain, but our system in Belgium, in Europe, our fiscal system, our social system is embedded in VAT. You pay value of what you produce in the country you produce. That's where we get our money from, our taxes. If we get anything on blockchain, where's the added value produced? It's gone. Our income, our state income is gone in Belgium. So it's so disruptive that technology is ready to do so, but we as on a global scale are not. But we could. Look how the world was disrupted with COVID. All of a sudden we had to produce mouth masks in manufacturing companies that were doing completely other stuff. A vessel got caught in the Suez Canal for what was it, 2 weeks? Look how economy on the ships was disrupted. This has to change. Strongly believe through technology, financial, economical impact. And you're right, it's so disruptive yet today that we don't know how to deal with it yet. But it's for the better, that I'm convinced of.
Yeah, totally agree. Totally agree with this.
I'm sorry, I don't want to interrupt the discussion, but we're coming to the end of the time we have set for this webinar. So, and unless Sarah and the others, if you have something very urgent, I would still suggest we should close it soon. I would like to actually thank everyone for attending, and would like to take a quick screenshot, like a group picture, where everyone could turn on their camera.